Okay, perfect. So last class, we talked a little bit about FOIL. Today we're gonna use FOIL to help us come up with some really interesting multiplication tricks. So I'm gonna first start off with 45 times 45. Let's go ahead and see what this product is. First, I want you guys to just calculate this value. It doesn't matter how you do it. I just want to see if you guys can come up with an answer. And then we'll talk a little bit about how to get the actual, like how to do this quickly, like super fast. Okay, also, just as a reminder, once again, make sure you're not using any calculators in these classes. It kind of defeats the purpose of the class if you use a calculator. So yeah, don't use a calculator. Okay, awesome. So I see a lot of people saying 2025, and I would agree with that. Okay, awesome. So Adik, I see you have your hand raised. Do you want to go ahead, unmute, and share how you got to this answer?
So I did 40 times 40, which I got 1,600. And then I did 5 times 5, which is 25. And then I added 1,625, and I got 1,625.
Good. Yeah, so I think there was a little bit of FOIL in there, which is absolutely correct. So you would do 40 times 40, which is 1,600, plus the 4 times 5, which is gonna be 200, plus another 5 times 40, which is 200, plus 5 times 5, which is 25, and that's how you get 2025. Okay, awesome. So FOIL definitely works. But there is a nicer way to do this. And before we go into that formula, let's take a look at the proof. So here's a question for you guys. How can you write 45 in terms of how can you write 45 in terms of place values? So take a look at how 45 is formed and break it down into its tens values and its ones values. Okay, let's see what you guys are saying. Awesome. Right. So you can write this as 4 tens and 5 ones. That is absolutely correct. So in general, we can write a two-digit number, AB, as 10A plus B. So let's go ahead and take that. Let's say we're squaring a number that ends with 5. If the number ends with 5, then my last digit is going to be 5. So that means B is equal to 5. So I can rewrite this as 10A plus 5. So really what I'm doing is I have 10A plus 5 times 10A plus 5. That is basically 10A plus 5 whole squared. Okay, and so if we do a little bit of distribution here, first I'm going to show each distribution in a different color. In this burgundy, we have 10A times 10A, and then we're going to add that with this yellow, it's like light yellow. Oops. And that's going to be multiplied by 5, so that will be 10A times 5. And then we're going to go ahead, add that with, let's do a green, 5 times 10A down here. So that will be, and then we're going to go ahead and add 5 times 5 in blue. Oh. Cool. So now if we take a look and expand this, what do we get from 10A times 10A? What is 10A times 10A? 100A. Okay, Avik, be careful. Remember that because this is 10A times 10A, it is 100A squared. So like Vaibahi says, 100A squared. Yeah, perfect. I see a lot of you guys correcting yourselves. That is absolutely correct. So this is 100A squared plus, what is 10A times 5? 50A, good. So this part is 50A. And this part is also 50A because it's the same numbers multiplied together. So in total, I have 100A. Awesome. And then I end with a 25. So if I take a look at how to rearrange this, I have 100a times a plus 1 plus 25. So basically, if I taking a look at place value, notice how the 25 is the last two terms. And then after that, I have two zeros and a plus 1. So basically, if we take a look at this part, this is kind of just like the product a times a plus 1 and then like 0, 0. But remember, I'm adding a 25. So then my first digits is basically a times a plus 1. These are my first digits, and then I end with a 25. Hold on. That division sign might be a little confusing. Okay, there we go. So basically, whenever we are multiplying by numbers ending with 5, what we do is we take the first digits, we add 1, and then we multiply those together and then add a 25 at the end. So for example, with 45 times 45, my first digits are just 4. So what I'm going to do is I'm going to do 4 times 4 plus 1, which is equal to 20. And then I'm going to have 5 times 5, which is 25. So I just stick a 25 at the end, and my final answer is 2025. So that is our general trick. Let's take a look at some applications of this and see if you guys can use that. All right, I'm gonna go ahead and minimize this proof. If you guys want to go back and look at the proof, that will be in the handout. But this was just like a general way of looking at the problem. Awesome. Okay. All right. So let's first start with, or actually, hold on. Let's move this over here. Okay, perfect. All right, so let's do a couple of example questions. First, can you guys find 95 times 95? What is 95 times 95? Yeah, 90, 25. The first digit is going to be 9, so we add 1 to that, we get 10. So 9 times 10 is 90, and then we add the 25 to the end. So whenever we're squaring a number ending in 5, we always add a 25 at the end. Okay, awesome. Let's do 195 times 195. I think this will be good. What is that? Yeah, good. 380, 25. That is absolutely correct. So even though we're now in the three digits, we're still doing the exact same process. So we're looking at the first two digits in this case, and that's 19. So we'll do 19 times 19 plus 1, which is 19 times 20, which is equal to 380. And then we just add the 25 at the end. So we get 380 and 25. And so our final answer is 38025. Awesome. Okay, so I see a couple of you guys have your hands up. If you don't have a question, go ahead and lower those hands. If you guys have like alternate strategies and other things, we can definitely discuss that at the end of class, but I want to make sure we get through all the content. So unless you have a question, keep your hands lowered. Okay, awesome. All right. Let's do a couple more before we move on. Here, I'll put a couple of examples for you guys, and then we'll go ahead and discuss them all together. So let me change colors. Okay, so I've got 65 squared. Let's do 5.5 squared. This one will be interesting. And then we can also do 125 squared. So go ahead, write your answers to these three questions, and then we'll go ahead and discuss. Okay, so for the first one, I see a lot of people saying 4225. So I'm going to go ahead and write that down and we'll check if that's right. Okay, for the second one, I see a lot of people saying, hold on. What do I see people saying for the second one? I think I missed it. 30.25. Okay, that's what I see most people saying. And then for the last one, I see a lot of people saying 15625. All right, let's take a look. So for this first question, we have 65 squared. So that's going to be 6 is the first digit times 6 plus 1, which is 7. So that's going to be 42, and then add a 25 at the end. So that's how we get 42/25. So this is correct. For 5.5 squared, don't be scared by that decimal. It's the exact same process, except we just have to account for a decimal at the end. So you can kind of think of it as like 55 squared. So we do 5 times 5 plus 1. So 5 times 6 is equal to 30. And then we have a 25 at the end. But remember, because we're squaring with a decimal, we have to move 2 places over. Good. So that's going to be 30.25. And then finally, we have 125 squared. We take those first 2 digits, which is 12, and then 12 times 12 plus 1 is 12 times 13, and that is 156. And then you add that 25 at the end, so you get 15625. Awesome. So these are all correct. Really great job. You guys are doing really good with this trick. Okay, Sharanya, I see you have your hand raised. Go ahead. What's your question?
So anytime there's a 5 at the end, there will always be a 25, even if the number's like really big, there's always going to be a 25.
Yes, that is correct. So anytime we're squaring a number with 5, we always end with a 25. That's absolutely correct. Awesome. Yeah, Mukta, go ahead.
Wait. So basically, we also learned like another strategy. It was basically
Yeah.
like,
I'm going to ask you, just so that we can go through all the content, can you save your strategy for the end so that way we can go through that?
fine.
Yeah? Okay, awesome. Alrighty. Okay, so let's go ahead, move on to a different trick. Alrighty. So now that we talked a little bit about how to multiply with numbers ending in 5, let's go ahead and talk about how to multiply two numbers whose ones digits sum to 10, and then they have the same tens digit. So let me go ahead and clear this. Okay, so our next question, we're going to be talking about how to multiply things like 43 times 47. So in this case, my tens digits are the same and my ones digits add to 10. So go ahead, you guys, and tell me what you think this answer is. Okay, so I see a lot of people saying 2021, which is really cool since this definitely was a pretty recent year. There are definitely multiple ways to do this. I think a lot of you guys are using the difference of squares trick, which is absolutely fine. That totally works. Yeah, so for a lot of these questions, for a lot of the multiplication tricks we're going to talk about, we have proofs in the handouts. I'm not going to go through every single proof because that would take a really, really long time, but I'm going to try to go through some of the more important ones. So if there's a multiplication trick and we don't go over the proof in class, check out the handout. That will most likely have the proof there. So for this trick, I am not going to go through the proof, but it is very, very similar to the previous proof that we just did. Okay, so basically, when we're multiplying two numbers with the ones digits adding to 10 and then the same tens digits, what we're going to do is we're going to take the first digits. So the first digit is 10, and we're going to do the first digit 4 times one more than that. So 4 plus 1. So that's going to give us a first digit of 20. And then we're going to go ahead and then multiply by the units digit, which is 3 times 7 is equal to 21. So this is actually just a very, very simplified version of FOIL. A lot of these proofs, a lot of these tricks come from FOIL and then finding patterns. So in this case, we're able to do 4 times 4 plus 1 is equal to 20, and then just multiply those last two digits to get 21. And then putting those two together, we get 20, 21. So I think Muktika asked, does this trick work for any number of digits? No, you would have to stay within the realm of 2 digits. Yeah. I think there is like a modified trick for like 3 or 4 digits, but that will have to be, yeah, I'll have to check that. Okay, awesome. All right, so take a look at 61 times 69. What do you guys get when you do that? Okay, I see a lot of people saying 4209. Okay, Parth, I saw your hand raised. Did you want to give a solution or did you want to ask a question?
Question.
Question? Okay, go ahead.
Are we gonna review the homework?
So solutions to the homework will be posted today. And if you guys have any questions about that, well, you're welcome to email me and we'll talk about that. Yeah?
Okay.
Okay, awesome. Tombi, do you have a question?
No, I accidentally kept my hand up.
Okay, no worries at all. Let me go ahead and, okay, perfect. You lowered that. Oh, okay, Sharonya, go ahead.
So like how did you get 4 plus 1?
Yeah, so I see a lot of people asking about 4 plus 1. This actually comes from the proof for this formula. Like I said before, we just don't have enough time to cover every single proof. So for now, I'm going to ask that you for it and then check out the proof in the handout. So whenever we're multiplying numbers like this, like in this form, we're going to do 4 times 4 plus 1 equal, and then that's going to be like how we get our first 2 digits. So there is a reason why we do 4 plus 1. It's just the proof is very, very long, or it's not very long. It's just like we don't have time to do that and then everything else, which is why I've chosen to exclude it. Okay, so yeah, I'm gonna go ahead and take a look at this question with y'all. Alrighty. So we have 61 times 69 is 4209, and I completely agree with that. This one is very interesting, and I like how a lot of you guys approach this. So first, this tens digit is 6, so we do 6 times 6 plus 1, which is equal to 42. And then we do 1 times 9, which is 9. But we don't just put these two numbers together like 429. I saw a lot of you guys already writing this as 0, 9. So we have to express this product as a 2-digit number. So even though 1 times 9 is 9, we write it as 0, 9. So this is incorrect. The correct answer is 4209. And that's how we get our final answer. Okay, awesome. So for those of you who are still having a little trouble like understanding this trick, think of it as very, very similar to the multiplication with like digits ending with 5 trick. So if we look at 45 times 45, notice how we are still adding we're doing 4 times 4 plus 1 for the first 2 digits. And then for the second 2 digits, we're doing 5 times 5. So this is 20, 25. It's the exact same trick. It's just a little bit faster with numbers ending in 5. So they're very similar, very much related. So hopefully that can help you remember this a little better. Okay, awesome. Okay, I'm just making sure that there's no questions in chat really quick. So sorry for the delay. Okay. All right, so Samantha asks, will there be +1 in the parentheses for every number? Yes. So basically whenever, we're always doing that 4 plus 1. We're taking the tens digit and then we're multiplying it by the tens digit plus 1. And that's how we get the first 2 digits. So yes, that is absolutely correct. Okay, awesome, awesome. Okay, perfect. All right, let's go ahead and move on. So let's do a couple more exercises with G's and make sure you guys have got the hang of it. So I'm going to post a couple of problems and then you guys are going to go ahead, tell me what you think. So I'm going to change to like a red. All right, so let's do 83 times 87, 64 times 66, and then 42 times 48. Let me know what you guys get for that. Okay, I see a lot of people saying 7221 for the first question, so I'm going to write that down for now. For the second question, I see people doing 4224. So I'll write that down. And then for the last one, I think I see 2016. You guys are super fast, so if I missed any of your answers, do let me know. Okay, let's take a look. So this first question, our tens digits are the same, and our ones digit 3 and 7 add to 10, so we can use our trick. We do 8 times 8 plus 1, so 8 times 9 gives us 72 for the first 2 digits, and then 3 times 7 are units digits. The product is 21, so 21 is our last 2 digits. Okay, awesome, so that is absolutely correct. All right, if we take a look at our second product, we have the first two digits are the same, and then the last two digits add up to 10. So 6 times 6 plus 1 is going to be 42. And then our last two digits are 4 times 6, which is 24. So 42, 24. I promise I didn't intend to like have the two digits repeating in the middle. It just happened to work out that way. Okay, and then for our last one, we have the first two digits match up, so the tens digits are the same, and then the last two digits once again add up to 10. So 4 is the 10th digit, so 4 times 4 plus 1 is going to be 20, and then 2 times 8, our units digit product, is 16. So 20, 16, that is our final answer for that last question. And someone said they were born in 2016. That is absolutely crazy. I was born in 2008, and 2016, I think I was in like maybe third grade. So that's pretty crazy in my mind. Okay, awesome. Okay, cool. Wow, so many 2016 kids. That's crazy, you guys. I feel really old. Okay, so let's take a look at another trick. Let me go ahead and minimize this. Okay. Okay, I think I saw Sid raise his hand and then he lowered it, so it's fine. Okay. All right, so the next thing we're going to talk about is multiplying two numbers, and the two numbers are close to and less than 100. So here's so what we're going to look at is products like 97 times 94. Can you guys do this? It's a little hard to foil, but I'm curious to see what you guys get. Okay, I see a lot of people saying 90, 28. Let me make sure that is actually correct. Okay, I actually disagree with almost every single one of you. Yeah, I don't think I agree with 9202, 9028. Okay, I see 9012 as a potential answer and then 9018. Okay, let's take a look at which one is correct because right now I see three answers in the chat. Alrighty. Oh, and then I also see 9228. Okay, I have to put all of these answers down. I want to see which one is correct. All right. So the trick for multiplying two numbers that are close to and less than 100, first, we want to find the differences of each number from 100. So how far is 97 from 100? Yeah, it's 3 away. So this is -3. What about 94? It's going to be 6 away. Good, so -6. So what we do is we subtract the difference from one number. I'll go ahead and pick a number, 97. Or actually, the difference from one number is -3. And we're going to subtract that from 94. So you're going to do, for the first two digits, you're going to do 94 minus 3. And then for the second two digits, I'm going to multiply my differences together. So this might seem kind of weird. Once again, the proof for this is going to be in the handout if you guys are interested in seeing why this works. I really do recommend you check it out. It definitely helps you get used to that like algebra, that kind of thinking. And it's easier to understand why it works than just blindly memorizing. So do check it out. But let's take a look. So what is 94 minus 3? 91. Okay, I already see people putting the answer together. Good, yeah, 94 minus 3 is 91, and then that last two digit is 18, so my final answer is actually 9118. So this is, oh wait, hold on. I think I miswrote one of the answers. Yeah, this is the correct answer. Good. Yeah, I know. When I kept seeing so many like 9028s in the chat, I was like, oh my gosh, did I miscalculate 97 times 94? So I just wanted to double check on that. But yeah, that's absolutely correct. And one interesting way to figure this out. So first of all, actually, you can immediately know that 9012 isn't the correct answer because if you take a look at the last two digits, we get 7 times 4, which is 28. So the number has to end with 8. So that's how we know that 9012 isn't the right answer. Okay, so let's I want to point out one more interesting thing, and then because we have a little extra time, we can actually go into this proof now that I'm looking at the time. Okay, so if you had instead decided to do 97 minus 6, notice that your first two digits is still 91. So it doesn't make a difference like which pairs of numbers you subtract. You just have to subtract one difference from the opposite number. So you can't do like 97 minus 3. That doesn't work. You have to do 94 minus 3 or 97 minus 6. And your first two digits should always be the same. And then your last two digits are always those differences multiplied together. Okay, good. So let's go ahead, or actually, hold on. Yeah, oh, thanks, Aditya. I see you put that in chat that you can do 97 minus 6. That's awesome. Yeah. Oh, Rensha asks if this is my job. No, this is not my job. I actually do not get paid to do this since this class is free. Yeah, this is not my job. Okay, Sharani, I see you have a question.
So, okay, yeah. So, like, can we do like any like subtraction equation in the 90s that has the last digit of 1, like 98 minus 7 or 99 minus 8? Or
You
like,
said,
do we have
yeah.
to do like a specific one?
So 91 so did you say 91 minus like 7?
No, 98 minus 7. Like,
Okay. So remember when we're doing like this subtraction stuff, what we're subtracting is the differences from 100. So if I was doing like 98 times 91, for example, my difference from 98 to 100 is 2. And then my difference from 91 to 100 is 9. So I would either do 98 minus 9 or 91 minus 2. And that's how I get my first two digits. And then my last two digits would just be 2 times 9. Okay, awesome. Hopefully that helped. Myra asked, do the numbers have to be 3 apart? No, absolutely not. So the difference between the numbers does not matter. You just have to find the differences between each number to 100. Awesome. Oh, Rensha asked what you guys can call me. You guys can call me Sam. Yeah, feel free to call me Sam. Okay, Shreyansh, I see you have a question. Go ahead.
Would it work if you had numbers over 100, like 102 times 106?
Yeah, so we're actually going to talk about that like in a little bit. So yes, it's a little different, the trick, but yeah, we'll talk about that. Oh, Sharania, that's what you were asking. Okay, sorry. For some reason I didn't understand that. But yeah, we'll talk about that. Okay, Shri Rob, I see you have a question. Really quick.
What's the limit until we can use this? Like, could we can't use it to like 97 times 50. So like, what's the limit that we could use this trick?
So the limit is however much you can multiply. This trick works for literally anything. Like I wouldn't recommend you use it on like 86 times 84 because that's just really hard to multiply. Those differences are hard to do. Plus you have to start accounting for carries at some point. So I would recommend like staying within the 90s. If you want to go into like maybe 87 in the 80s, I would say don't go lower than 87. Yeah, okay. Awesome. No problem. Okay, and then Ahanika, really, this is going to be the last question, so go ahead.
Does the same strategy work on for like numbers past the thousands? Like, does it still work for that, or is it only until the hundreds?
So this works for numbers both close to and less than 1,000. Yeah, it's just a little modified. Instead, we try to find the differences to 1,000 instead of 100, and then we apply the exact same trick. So yeah, that works then as well.
Okay.
Awesome. And then Samanvi asks, do you have to multiply to 100 or any number close like 80? So you always have to multiply you always have to go to 100. You never look at the difference from like 97 to 80. You always look like 97 to 100. Okay, awesome. So these are our last questions. Let's go ahead, take a look at this proof, and then we'll do a couple of more practices. So let me change to a different color. I don't want to bore you guys with all the same numbers. Can it work above 1,000? So the proof for multiplying numbers above 1,000 is slightly different, but we'll talk about that in the next question. No, this does not work for division since this is multiplication. Yeah. Okay. So let's say we have two numbers and we can write them as 100 minus A and 100 minus B. So in the example above, our A could be 3 and our B could be 6. So 100 minus 3 gives us the 97 and 100 minus 6 gives us that 94. So Yeah. Okay. Once again, just a quick reminder, make sure you guys aren't like spamming in the chat, because if I see like a lot of like random stuff that isn't related to what we're doing, I'm gonna have to close the chat. Okay. Awesome. So let's take a look. When we go ahead and multiply these numbers, hold on, I just realized my spacing was really bad. Okay. Cool. All right, let's go ahead and do a little bit of FOIL. As you can see, this FOIL pops up a lot. So yeah, we're gonna do 100 times 100 times 100, and then this, and then this. Okay, so we have 100 times 100 plus negative b times 100 plus negative a times 100 plus negative a times negative b. So take a couple of seconds and see what you get when you expand this. Yeah, once again, make sure you guys aren't spamming in the chat. It kind of hurts like those who actually have questions to ask in the chat. So yeah, please do stop spamming. Okay, Vaibahi DM me. She said that she got 100,000 plus, or actually, hold on. Minus 100a minus 100b plus ab. And I absolutely agree with this. This is absolutely correct. So 100 times 100 gives us 10,000. And then negative b times 100 gives us negative 100b. Same for the negative a times 100 gives us negative 100a. And then negative a times negative b gives us ab. Good. So what we can do is we can group these two terms to get 100 times 100 minus a minus b plus ab. So if you think about it, this 100, oh, I wrote 100,000. Oh, I meant to say 10,000. I don't know if I said 100,000. I meant to say 10,000. Okay, if you think about it, isn't this what we started with? Isn't this one of our numbers? 100 minus a? Isn't that this over here? That's the same thing, right? So what we're doing is we're taking that first number, and then we're just subtracting the difference from 100 for the second number. So we get that number minus that second difference, and that's how we get the first two digits. And then the last two digits is just going to be that product of the differences. Okay, if you guys are confused about that, put your questions in the chat. Yeah, Sharon, you go ahead, put your question in the chat. Same with you, Thunbi, so that way we can quickly get through those. Awesome, thanks you guys. Okay, perfect. If you are confused about like this expansion, I can go through that once more. Or if you're confused about like how we're doing this grouping stuff, I'll go through that again as well. Okay, and like I said before, this proof also applies to multiplying two numbers that are both close to and less than 1,000. Okay, awesome. Okay, I think a couple of people are pretty confused. So I'm going to take a question. I'm going to do this with an actual problem, and then we'll go through this together. Also, yes, the recording is available, so you guys are definitely welcome to go back and look at this. Okay, so let's take a look at, so recordings are always sent out after class, and yeah, that'll be sent out in a separate email. Okay, let's take a look at the product 91 times 99. So I can write 91 as 100 minus 9, and I can write 99 as, or actually, let me pick a different number. Let's do like 98. I can write 98 as 100 minus 2. What do you guys think of that? Do you guys agree with that? Yeah? Okay, awesome. So I see a lot of people agreeing with that, which is perfect. So in this case, let's let this equal A and this equal B. So what I'm doing is I'm doing 100 minus 9 times 100 minus 2, where A is 9 and B is 2. So take a look at this form once again. Do you guys see the parallels to that? Do you see how they're similar? Good. Okay, awesome. So now what I'm doing is I'm going through expanding all of this. If you guys want to take a look at that expansion once again, I recommend you go take a look at the recording where I explained it originally. So we get to this last portion over here, and I think this is where a lot of people got confused, which is totally okay. So what I did was I pulled out that 100 factor in the first three terms because I want to find I want to find a nice way to get those first two digits, and those first two digits are some two-digit number multiplied by 100. So that's why I'm trying to pull out that factor of 100. So when I do that, I get 100 times 100 minus a minus b. Okay, does that part make sense? Yes? Okay, awesome. So if you look at the 100 minus a minus b, notice that we actually have one of our starting numbers in here. Isn't 100 minus a something that we started with? Yeah? Yeah, we started with 100 minus a, remember? Because that's one of our factors up here. So we definitely started with 100 minus a. And then we said that b is another difference. So if I'm taking a look at my example, 100 minus 9 times 100 minus 2, and I said that a is 9 and b is 2, I said 100 minus a is 100 minus 9, so this is 91. And then my b is 2, so 91 minus 2 is equal to what? 89, good. So what are my first two digits? Yeah, they're going to be 89. That's absolutely correct. So I have 89 at the front. And then can you guys tell me what my last digits are? 18, absolutely correct. I did see one person put in 08. Remember, this trick isn't multiplying the last two digits, it's multiplying the differences. So my differences are 2 and 9. So I do 2 times 9 gives me 18. So my last two digits are 18. Okay, hopefully this makes a little bit more sense. If it doesn't, definitely go back, check out that video or the recording. And if you guys still have questions after that, feel free to email me. Okay, let's do one last example before we move on to our final, or actually, yeah, let's do one last example before moving on to our last trick. So, can you guys find 89 times 93? Yeah, this one's okay. Okay, what do you guys get for this? Yeah, so recordings of class will always be sent out in emails. So yeah, you guys will all be able to see this recording. Okay, I see a lot of people saying 8277, and that is absolutely correct. Okay, so the difference from 100 and 89 is 11. Actually, let me write this difference in a different color just so that you guys are able to tell. So this is 11. And then from 93 to 100 is 7. So if I do like 89 minus 7, I get the first two digits of 82, and then I multiply my differences. So 11 times 7 gives me 77. So putting those together, I get my final answer of 8277. Okay, awesome. So that is how you multiply numbers that are close to and less than 100. Let's now talk about numbers that are close to and greater than 100, since I saw a couple of you guys asking about that, which is a very nicely asked question. So let's take a look. In my opinion, this trick is more fun because it's a lot easier to remember. So I want you guys to first start off by looking at the product 103 times 107. Can anyone tell me what this might be? It's okay if you don't know. I mean, these are three-digit numbers, so it's kind of difficult to multiply. But what do you guys think the answer is? Okay, I see a lot of people saying 11021, and that is absolutely correct. So the proof for this is very, very similar to the previous proof. Instead of subtracting, though, we're just adding. So it's very, very similar. If you guys want to like do that on your own, you are so welcome to. But yeah, let's take a look. So what I'm basically doing is I'm looking at the difference from 100. So this is obviously 3 greater than 100, and this is 7 greater than 100. And then I'm gonna do each one added together. So I'm going to do 103 plus 7. And that's how I get my first three digits of 110. Then I'm going to do my last two digits, my differences, 3 times 7 multiplied together, and that is going to be 21. So putting that together, I get my final answer of 11021. Okay, awesome. Parth, I see you have your hand raised. Do you want to go ahead, ask your question?
Can we, if the FOIL strategy is easier for us, can we use that?
Absolutely, yes. So in this case, I really do think it is a little faster to use the looking at the differences and things. Sometimes you might find FOIL a little easier. It just depends on your scenario, like which solution you think is best. But yeah, most of these tricks are faster than FOIL, in my opinion. Yeah, Sharanya, go ahead.
So just like 5 times 5 ends in like 25, would 3 and 7 always end in 21?
No. So sometimes you'll get like carries and things involved. It's just in the cases that we've done so far, we have ended in 21. But yeah, sometimes there are other like carries involved in things. Okay, awesome. Cool. All right, let me just go ahead and make sure everyone's muted because I think I forgot to change that before. Okay, perfect. Let's take a look at a couple of other questions before we move on. So can you guys okay, this one's a little trickier. Actually, hold on. I'll just give you all 3 problems at once. There's going to be a couple of tricky ones in here. So take a look at 104 times 105, and then 111 times 108, and then our tricky one of 112 times 114. So what are the answers to these questions? Okay, I see for the first one, people putting 10920, so we'll see if that's right. For the second one, I see people putting 119, hold on. I think I saw 980. I'm not sure if that's right. Let me put that down though. Oh wait, never mind. I'm seeing 988. Okay, just kidding. All right, and then what about for the third one? What do you guys think for that one? Okay, I don't actually see any questions. Oh, okay, I see 126, I think I see 12668. All right, let's take a look at each of these. So for the first one, my differences from 100 are 4 and 5. The reason why this trick is so easy is because it's very easy to see the differences. Like 4 and 5, those are the units digits. I don't have to do any extra subtraction or anything. So I do 104 plus 5. I get my first 3 digits of 109, and then I multiply 4 times 5 to get that last digit of 20. Awesome. And then I also have, for the next question, 111 times 108. So I have my differences of 11 and 8. So I do 111 plus 8, and that gives me 119. And then I'd have 11 times 8 for my last 2 digits to get 88. And then finally, for the last one. Okay, the last one, I think a lot of people are a little bit confused, which is totally okay. So for that first, okay, so Arisha's asking, how do we get the first 3 digits? Yeah, let's take a look. So for the first question, for the first part, what is the difference from 112 and 100? How far is, yeah, good, it's 12. Okay, perfect. What about 114 and 100? 14, absolutely. So what we're doing is we're going to do 100 plus 12 plus 14. So what is that? What is that sum? 126, good. I'm not going to write down my 126 yet. Instead, I'm going to do I'm going to do 12 times 14. What is 12 times 14? 168, good. And you do this using difference of squares. Now, in all the problems that we've previously encountered, we only have 2-digit last numbers, but now we have 3. So what are we going to do with that extra digit? Yeah, I see a lot of people saying we're going to carry. That is absolutely correct. So we're going to carry the 1. Instead of writing like 12668 or doing like 126168, which is way too many digits, we're going to carry that 1 and add 126 plus 1 to get 12768. And that is our final answer. Okay, awesome. Yeah, make sure you guys are being like polite in the chat. I am seeing like some like mean comments and things. And if I continue to see that, I am going to close the chat. Okay, awesome. Let's go ahead and take a look at a couple more tricks and yeah, go from there. All right. So let's look at multiplication with two numbers close to 100, but one is above 100 and one is below 100. So this one's going to be interesting. So go ahead, take a look at 93 times 104. Okay. Because of like time and things for now, if you guys have a question, go ahead, put your questions in the chat and I'll answer them there. Okay, perfect. Okay, so I see a lot of people saying 9672. Yeah, so let's see. Oh wait, that's not what I was going to try to do. All right. Let's see if this is correct. So, what we're going to do with this trick, once again, the proof is a little lengthy, and since we're running a little short in time, you guys are welcome to check out the proof separately, but it's there. There's a reason why this all works. So I would recommend you guys take a look at it. The reasoning and how we get to the proof is very, very similar as the rest of the proofs that we've done. So it's nothing new, and you should totally be able to like handle it, understand how it works. So yeah. Okay, let's first start. Well, okay, based on what we've done for the other two proofs, what do you guys think I'm going to start by doing? What do you think is our first step? What has been our first step for like multiplying with numbers less than 100 or multiplying greater than 100? Yeah, we're going to find how far it is from 100. That's absolutely correct. So how far is 93 from 100? Yeah, 7. Good job. Okay, and then how far is 104 from 100? 4. Absolutely. Perfect. So for this trick, what we're going to do is we're going to take that 3-digit number, so the one greater than 100, and we're going to subtract one more than our other difference. So for example, what I'm going to do is I'm going to do 104 minus 7 plus 1 for my first 3 digits, for my first 2 digits. So what are my first 2 digits? What do you guys get when you do 104 minus 7 plus 1? Good. I see a lot of people saying 96, and that is absolutely correct. Good. And then for my last 2 digits, I'm going to do 100 minus 7 times 4. So I'm going to subtract the product of those two numbers. So what is that? What does that come out to be? 72, absolutely. So putting that together, I get 96, 72, and that is actually my final answer. Great job. So this trick is a little bit more involved, and if you find that you're better at like doing some FOIL or you're better at just doing like 93 times 100 plus 93 times 4, that's totally okay. You can do whichever you think is fastest for you. I do believe that if you do this trick a lot, it is a lot faster. Sharanya, if you want to go ahead, put your answer or question in chat, that would be great. Okay, so Manvi asked how you got to 96. So to get to the 96, what we're doing is we're taking that larger number, and then we're subtracting one more than the difference for the other number. So if I have 7 as my difference for 93, I'm just going to do 7 plus 1, get 8, and I'm going to do 104 minus 8. So that's how we get to 96. Ahanaka, if you want to go ahead, put your answer or question in the chat, that would be great. Okay, awesome. Yeah, so you're always doing that extra plus 1 for every time. Yeah. Okay, perfect. Good. Okay, yeah, so we can absolutely do another question. Yeah, I know this one is a little hard, so yeah, let's take a look at one more. All right. Can you guys do let me change colors. Let's do 108 times 95. It's okay if you take your time on this. I know it's a little bit involved, so. Okay, so I see a lot of people saying 10260. So let's go ahead and see if that is right. So the first step we want to find those differences from 100. Okay, so Hanukkah, I think so you said you didn't understand how we did that first example. We're gonna go through the second example, hopefully a little bit slower, so that will make a little bit more sense to you. Okay, we're gonna first start off by finding these differences from 100. So how far is 108 from 100? 8, absolutely correct. And then how far is 95 from 100? 5, good. So what I'm gonna do is I'm gonna do 108 minus 5 plus 1. Remember, I always add plus 1 to that smaller difference. Well, not the smaller difference, to that negative difference. So plus 1. So what is 108 minus 5 plus 1? Yeah, 102, absolutely. Once again, you guys, if you continue spamming, I am going to cut off the chat. I know even though it's at the end of, towards the end of class, I will cut the chat off. Okay, and then what do we get for those last two digits? Well, we have 100 minus the product of the differences. So 8 times 5, 100 minus 8 times 5 is going to be what value? 60. Perfect. So putting those together, we get our final answer of 10260. So hopefully that made a little bit more sense. If not, I recommend you look at that recording once again so you can see like how we got each of those parts. And then I also recommend you check out that proof, because that proof also explains like why we're adding plus 1 and doing some of these other things. So yeah, hopefully this makes a little bit more sense. I know it is a little bit involved, but as you can see, a lot of you guys did it the second time and got it way faster already. So if you continue practicing with this trick, I think it'll come to you like that. Okay. Yeah, it is definitely easier as the more you do it. Okay, we're gonna end with one last trick before we end class. So yeah, this one is going back to ending numbers with 5. So I think it'll be a little easier than the one that we just did. Actually, if we finish this one a little bit faster, we might also cover exponent rules really quick. Okay. All right, so let's take a look. So instead of like squaring now, I'm just gonna do two numbers ending in 5. So let's take a look at 45 times 65. Do you guys have any ideas for what this answer is? Okay, so I see a lot of people saying, so I see some people saying 29, 25, and then I see some people saying 24, 25. So let's take a look. Once again, proof for this is going to be in the handout. So definitely for this lesson in particular, it's really important that you guys really go through that handout, read through the proofs so that you understand like why some of these tricks work. Okay, so for the front two digits, what we're going to do is we're going to take the product of the first two digits, 4 and 6. So I'm going to do 4 times 6, and then I'm going to do the average of these tens digits. So 4 plus 6 over 2. And if my sum happens to be odd, I'm going to ignore any remainder. So I'm just going to take the quotient and ignore the remainder. So in this case, what do I get for my first two digits? I would get 29, good, because 4 times 6 is 24, and then 4 plus 6 is 10, divided by 2 is 5, so I get 29. Okay, and since my first two digits have the same parity, and by parity, I mean they are both even or both odd. In this case, they're both even. Then I will end with 25. So my last two digits are going to be 25. So that's what my final answer is, 29, 25, not 24, 25. Okay, so instead, if we had like an odd first digit and an even first digit, I would end with 75. So basically, if you were having a remainder when you get that average, we end in 75. So let's take a look at that kind of example. So let's do 35 times 85. First of all, what are my last two digits? Be careful. Are these two the same? Are these two both even and both odd for that first digit? No, yeah. So because the first digits are not like both even or both odd, we have to end with 75. Good. So we only end with 25 if our first two digits are both even or both odd. If I have one even, one odd, I end with 75. Good. And then can you guys tell me what my first two digits might be? 29. Really good. So I have 3 times 8 plus 3 plus 8 over 2. And then I ignore the remainder. So 3 times 8 is 24. And then 3 plus 8 over 2 is going to be 5 and then 1/2. But I ignore that 1/2 remainder and then I just get plus 5. So my first 2 digits are 29. So my final answer is 2975. So I see a couple of questions. Someone asked, does this work only for numbers ending in 5? Yes, this only works if your number ends in 5. Also, I saw someone asking about like an even and an odd thing. So what I mean by that is you have to look at your tens digits. And if your tens digits are both even and both odd, or if your tens digits are both even or both odd, then you end with 25. So in other words, the way you want to think about that is like if the average of those first 2 digits is a whole number, like there is no remainder, you end in 25. Otherwise, if you have like one even tens digit and an odd tens digit, you end in 75. This does only, well, you can extend this to 3-digit numbers. It just gets more complicated. So I would recommend staying with 1-digit numbers, or sorry, 2-digit numbers. Okay. Yeah, Viba, he put it in chat, even and even or odd and odd ends with 25, and if it's even odd, 75. And when we're talking about that, we're looking at the tens digit. Yes, Samanvi, to your question, that is correct. Let me just make sure there are no other questions. Okay. Okay, so Riddler asked when the number is ending in 5, you have to put a 25 at the end. Remember, be careful about what I just said. You have to look at the parity or like how, like whether a number is even or odd for the first 2 digits, for the tens digit. Okay, awesome. Sharanya, go ahead, unmute and ask your question.
I actually wanted to share a trick for squares.
Okay, perfect. Let me just go ahead and end class officially, and then we can go ahead and talk tricks. I know Muktika, if you're still here, you also had a trick to share. So if you want to go ahead and wait until the end of class and share that, that would be really cool. Okay, awesome. So everyone, thank you again so much for coming. Hopefully you learned a little bit more about like some new multiplication tricks, and this will help you be a little faster in the number sense. I know this stuff like this comes up all the time. So being able to recognize it, use these tricks, hopefully will help you guys. So thanks again for coming. And yeah, have a great night, you guys, and I will see you all next week. All right, bye everyone. And then if you guys had something else to share, you are welcome to stay and we'll talk about that. Okay, awesome. And then I know someone asked me before, like if I did math league and stuff. Yes, I did. I didn't want to answer in the middle of class since like we were learning and things, but yeah, I did math league back when I was in elementary school, and I did a lot of number sense. Number sense was my favorite round. Savannah asks if I like math. Yes, I love math. Of course, I love math. Math is really awesome. Awesome. Okay, bye you guys. Thanks again so much for coming. Yeah. Oh, Rensha asked what place did I get? When I did the last time I did elementary math, like, oh gosh, that was so long ago. That was like I think 2019, maybe 2018. I went to nationals and then I got second place there. And then after that, I haven't done as much math league. But yeah. Awesome. Okay, thanks everyone so much for coming. I so appreciate it. Yeah. Bye, Aaron. Of course, I'm happy to help. And you are welcome to call me Sam. I'm not much older than most of you guys, so you guys are so welcome to call me Sam. Vibehi asks, where do we find the homework? Yeah, the homework will be emailed to you as well as a recording of the class. So you guys will get all those resources. Yeah. Oh, someone asked if I got a perfect number sense score. Yes, I did one time. I did get a perfect number sense score. Awesome. Okay. Yeah. Bye. Happy Valentine's Day, everyone. Yeah. I forgot to say that last time. Okay, awesome. Yes. Okay, so Muktika, I know very early on you had an extra method. So I'm gonna go ahead and let you share that now. So yeah, if you want to raise your hand, that way I can call on you to unmute. Okay, perfect. Go ahead.
So basically it was like let's take 45 squared for example. Basically you would take like 40 and then you would square it, and then you would take 5 and square it, right? And then what 1600 plus like 25, 1625, and like next it would be like you have to like multiply it by 2, right? Like something like that.
Oh, I don't know where that multiplication from 2 is coming from.
Like it's like 4 times 5 times 2, I guess. Like I don't know.
Yeah, because if you do 4 times 5 times 2, that gives you 40. So that's actually not anywhere in the answer. However, if you do that 4 times 5, that's how you get the strategy we were using. And then instead you would get like that 2025. So I think you were learning the exact same strategy we talked about in class today. You might have just gotten a little bit confused. Yeah.
No, it was like a different strategy, but I forgot one of the steps.
Oh,
Like
okay.
I got
Well,
confused with it.
if you remember it, you're welcome to email me with it. I would love to
Okay.
hear about it.
Wait, I also realized a pattern about squares. Like 1 square and 9 square, they both end with a 1, and then 2 square and 8 square, they both end. Wait, no, 2 square and 2 square and 8 square, they end with 4. 3 square and 7 square end with a 9, and like 4 square and 6 square, yeah, they both end with a 6, and then 5 square is all alone.
Yes, 5 is all alone. Yeah, that's really good. I'm glad you noticed patterns like that. And we'll talk a lot more about like patterns with like squares and things all the way like in another class. So yeah, that is definitely something we'll bring up. But that's really cool that you notice those kinds of patterns.
Okay,
Okay.
bye. Thank
Sean,
you.
oh yeah, of course. Thank you so much for staying after and explaining that. Okay. Sharanya, do you want to go ahead say your other solution? Oh, bye, Shriram. Of course. Thank you so much for coming. Yeah, bye, Sivduka. Okay. Oh, Sharanya, I think Sharanya is just gone. Okay, that's fine. Shreyansh, I think you had a question before Pooja did. Shreyansh, do you want to go ahead, ask your question?
Yeah, what's your average score in the number sense?
Gosh, I don't remember. I took the number sense a while ago, so I would say, man, I don't know. I would definitely say it's above like 200, maybe a little closer to 300. But yeah, it's been a really long time since I've taken a number sense, so I really couldn't tell you accurately.
Okay, bye.
Yeah, of course. Bye. Happy Valentine's Day. Okay, Pooja, go ahead. What's your question?
It's recording because I just joined today.
Absolutely, yes. We'll send the recordings as well. And if I somehow forget to send you that other recording, just follow up with that email and we'll get that to you for sure.
Okay, thank you.
Of course, yeah. Awesome. Okay, if there are no other questions, I'm gonna go ahead and end the meeting. For those of you guys that are still there, happy Valentine's Day. And yeah. Oh, okay, one last question. Nishala, go ahead.
If we didn't talk about this in class, but if we have like numbers from like 51 and 201, how can you find if there's like if they're asking for like prime numbers?
Okay, so this is a prime factorization question, and we're actually going to go over prime factorization next week. So I'm going to leave this for next week. Is that okay?
Sure.
Yeah? Okay, awesome. All right, thank you guys so much for joining me. I'm going to go ahead and end this meeting, and then I'll follow you guys. I'll send you guys a follow-up email with the recording and then the homework. So thanks again for joining me, you guys. Bye, good night.